Okay, hey guys, I'm back, and this is microphone number 2 for the upcoming contest. Okay, so, Crack Spider 101 said that I didn't explain the 5x7 LED matrix code, which is what this is here, this code. He said I didn't explain it well enough, so I'm going to try again to see if I can do better, because, just as a reference, feel free to do this, in the future, because I really like it when people do this, because it lets me know what I'm doing right and wrong so I can make my videos better, which is my ultimate goal, is to make my videos really good so lots of people can understand what I'm trying to get across. And also, for this video, usually Hypercam 2 I pause it, but since lately when I pause it, hit stop, I've been stopping it, so I've had to record this 3 times over. I'm going to try, so if you hear a pause, or you hear me stuttering, that's because I'm trying to figure out where I am on my script, and what I'm going to say next, so just sort of go with the flow, because I don't really feel like stopping this one too much, because it gets the audio out of sync, and it gets me out of sync, so you're just going to sort of have to, work around that. So, let's get started here. Okay, so to start out, we have an integer I, and does something with a for loop. I'll explain it later. So after that, we're just going to start in void setup. What void setup is it happens once right after the microcontroller boots up, but only once, okay? So we're just going to start by declaring everything. Sorry, I took this from the Blink sketch, so all of these things are from the Blink. Anyway, I highly recommend doing that. I don't ever recommend starting from a blank Arduino sketch or a blank code. Anything for that matter. I recommend starting with code that you know works, like the Blink code, and then taking it from there, because it just ensures that you haven't done something like maybe this. You changed it to like you just forgot the dash or something, and it locked up Arduino environment. Oh, no, it didn't. There we go. Okay, but anyway, if we put back the dash, you can see that everything works now. Oops, and I just lost my place. Okay, so we output everything. We set everything as output because we want to turn the LEDs on. Okay, we don't want to input to them. We want to output to them, put current to them, and we want to light them up essentially. So then here we have a void loop, and what happens is what's inside this loop will repeat forever and ever and ever, and it will just always keep on going. Okay? So okay, so right here we have a for loop. This for loop repeats what's inside it 150 times, as you can see here, 150. Okay? What this first block of code here does is it turns on the first, second, and third row of LEDs green color. And it does this by writing what we're not using high, because the pins default to low. And if a row, which is your cathodes, are connected to your rows, and your anodes are connected to your columns. And if a row is pulled low and the columns are pulled high, it will light up the lights in that row, and that would result in extra lights being on. So what this first block of code does, as I've said, is turns on the first, second, and third rows. And as you can see, that green color, just as you can see, it is this first line turns the first row. It says pull the first row low, meaning that now the cathodes for the first row are connected to the ground, and since everything else that's not being used is connected to high, that means the anodes in the first row are connected to positive, and then because if you connect the positive LED to positive and the negative to negative, it'll turn on. So now all 3 lights in the first row are on. This one, same thing except with the second row, pulls the second row low. So now all the lights in the first and second row are on. And this one, same thing with the third row. Okay? Okay, so what this delay 1 here means is that whatever we've just done before, we just leave it for 1 millisecond. And a millisecond is 1,000th of a second if you didn't know. So that means that we're just leaving the first, second, and third row on, creating a solid rectangle. We're just leaving that rectangle on for 1,000th of a second. what this code block here does is it turns everything off. And you're saying, well, aren't the anodes connected to positive? Yes, they are, but so are the cathodes. So if you ever tried putting the cathode and the anode of an LED, or in a sense both legs of the LED, to the positive rail, you'll see that it won't light on. You have to have one positive and one negative. So by putting everything to positive here, we just ensure that everything is off, okay? Now we leave it off for 1 second, okay? We just leave everything off for not 1 second, 1 millisecond, okay? This little code block, I'll go through later. And then this is what ends the for loop, meaning this entire thing is repeated 150 times, okay? Then it moves on to the next one. Okay? This is the same for loop, repeats what's inside it 150 times. Okay, so guys, in this first block of code here, what we do is we pull what we do is we pull the first row and the third row, we turn those on, but this time we're turning on the red color, not the green color. So the way we do this is by connecting the first row to ground, and since cathodes are connected to the first row, and since everything else is connected high, including the red anodes, or the columns, the red columns, that means that current will flow through the first, second, and third columns into this first row, causing all of the lights in the first row to turn on, making it red. Same thing with this, which pulls the second row low, the third row low, and then that creates like this, like if these were our 3 rows in our display, this first row would be on, as well as this third row. But I can't really do that with the mouse. It's hard to show you. Maybe 1 second. Whoa. Okay, that's weird. 1 sec. Let me try to fix this. There we go. That's better. Okay. So this one would pull the third row low, red color, the red third row low, and that means that current will flow to the same first, second, and third rows and turn on the third row. Okay? The second row, though, is not pulled low, meaning that it won't turn on, only the first and the third will. We just leave that for 1 millisecond with its delay. You already know how this turns everything off, so we just leave everything off. And then what we do here is... Okay, so, sorry about that. I got lost in my script. So what we do here is we turn on the first light in the second row and the fourth light in the second row, but we don't turn anything on in the first row or anything on in the third row or the middle 2 lights in the second row, okay? We're being very specific here. So, as you can see is, right here, what this statement does is it pulls the second row low, meaning that now current can, the lights in the second row can be lit up, okay? Now, you would think that since everything we're not using is pulled high, that means that wouldn't everything in the second row be turned on? That's not the case, because we only, well, shouldn't be the case, and it isn't, because we only want the first and the fourth lights to light up, not the second or third. So, the way we do that is we just leave, since everything defaults, since I've made everything turn high, if it's not, I just copied, what I did to write it is I just copied this and then turned what I want low, so that way there wouldn't be erroneous lows, extra lows in your, in my code. High and low are getting to sound really repetitive now, because I've said them about 20 bajillion times, and I'm banging my head on my computer. Just because I hear this so much. If you don't realize it, if you count how many times I've said a couple words, I've said so many words like row, column, anode, low, high, LED, on, off, red, green, so many times, it's getting really annoying. But I guess that's something I gotta sacrifice, as well as writing this script right here, which I've deviated so much from, because that's what I love to do. But anyway, what this does is this is the, oh, and yeah, this is red color, by the way. This entire block is all doing red color. Okay, just to let you know that, because I probably forgot to mention it. So as we said, this one is doing the second row low, so that means that now lights in the second row can be turned on. Since the first row, and I'm not sure which one is the third row. I know that one's the first row. But since in the first and the third row, that might be the third row, are turned high, that means that the lights in the first or the third row can't go on, so we don't have to worry about that. What this does is this is the second light. This is the second column, okay? That turns that low, meaning that now the second column cannot be lit up because there's no power flowing into it. And this is the third column. So now, since whatever the first and the fourth columns are, whatever, because those default to high, well, actually the pins default to low, but in my sketch, since I copied and pasted it like I did, they default to high. Now the first and the fourth are turned on, okay? We leave that one for 1 millisecond. We turn everything off. You know how we do that. We leave that for 1 millisecond. And this block of code right here. What this does is what this first block of, is it turns on the middle two lights in the second row on. It turns them on, but in a green color. So now it looks like there's a red border surrounding two green lights. The way it does this is it's very similar to what this one up here we just went over, in how that one right here, the one we just went over, only turns on the outer two. This one works very much the same way in how it only turns on the inner two. Is it pulls the second row low, meaning that now the second row can be turned. Those lights can be turned on, because if it was pulled high, they couldn't be. So now the second row can be used, and this is this code block right here. This is a green color lights here, if I forgot to mention that before. And then what it does is, if you remember in the last one, what it did is it pulled the first and the fourth column low. This one, it pulled the second and third one low. This one pulls the first one and the fourth one low, so that now those first and fourth lights are off, and then the second and third are on, making it so that there's a little chunk in the middle like this, out of your whole row like this. So you have the first light in the second row off because that column is being pulled low. You have the second and third one on because their columns are being pulled high and the row is being pulled low, which makes the anodes attached to the positive, the cathodes attached to the negative to make them light up, and the fourth one, the column is low, which makes the anode attached to low and the cathode attached to low as well. This code, again, I said I'll go over it later, and then this you're ending to your for loop. This code is the exact same code we've seen before. This was the very first block of the first for loop we went over, if you remember. This for loop right here. Oops. This for loop right here, if you remember, this is the very first one we went over. So, let me get to it. This one right here, right? This for loop is almost the exact same code, except that instead of making a box of solid green color, it makes a box of solid red color. So basically, it's just switching them from the green columns and the green rows to the red columns and the red rows. So you already know how this for loop works, so no need to go over that. This for loop is like the one that we also did the second for loop that we went over, if you remember. Because what it does is it creates an outer square that sort of borders an inner square, except for this time it makes the outer square yellow and the inner square red, so you know how the red one's done. The yellow is a bit more complicated, but I don't need to go over it in detail, and I certainly won't explain to you what each line does in it. But in the yellow, basically what it does is it just turns on the red lights and the green lights at the same exact time, so nothing fancy there. So you already know how that code works, so we'll keep going on. to this for loop, which is exactly like the first for loop in the sketch, in that it just creates a box now of solid yellow. And from how that's done, you can see that these first two are low, and these four, and that pulls, this one is the first line green, second line green, third line green, and by line I meant row, and this is first row red, first row red, and first row red, pulls them all low, we get a yellow color. And then this one surrounds 2 little pixels of yellow by a border of green, and you already know how that one's done, because it's just like the code that we've already been over about 20 bajillion times. I'm getting so tired of looking at this code now. Anyway, what it does is, like I said, it just makes a border of green surrounding yellow, and it's the same as the code we went over, except for that instead of having a border of green surrounding red, it has a border of yellow surrounding, sorry, a border of green, okay, the code we went over before was a border of red surrounding green. This is a border of green surrounding yellow. So the border of green, that's exactly like the border of red, except in a green color, and the 2 little yellow dots in the middle are exactly like the 2 green dots in the middle, except for the fact that I've also turned on the 2 red dots in the middle, okay? And so that is that. As you can see, this is the end of the code. 433 lines of code, although these empty lines are counted as well. So there's probably a much more line-efficient way to do this, but I put this code together in about an hour. It was pretty fast, simple. All I had to do was copy these blank ones and change the rows that I wanted to be just this one. What I did to write it, I'll show you how I wrote it, is you can get into my head a little when I was writing this, is I copied that code and I pasted it, and then what I did is I changed the rows that I wanted to be on to low, and the columns that I didn't want to be on to low, and then I just hit delay 1 and then pasted it again and did the same exact thing. Okay? But there's this code that I haven't been over. Now, this code, as you can see, we have a delay 1, fairly simple. We just delay 1 millisecond. Okay? So, oh, well, I can move this box here. Woo! You're most likely seeing some really crazy thing on the screen right now. Okay. Anyway, this delay 1, I just figured out how to do that. I'm so excited. This delay 1 delays 1 millisecond. This if I is equal to 999, I is what keeps getting incremented in the for loop, meaning that every time this for loop goes through, I gains 1 more, okay? And it does this until it gets 150. That's how the for loop only repeats everything in it 150 times. So I'm saying that if I is equal to 999, get out of the for loop. That's what a break statement is. Okay? A break statement gets you out of the loop. Although I highly doubt that that little bit of code is necessary. You could I mean, it works for my design, it works, so I didn't bother to actually analyze it. I probably should have. But it doesn't make much sense to me because I can only get up to 150. As you can see, I is less than 150. So, I don't know. But it worked in my design. So, if you want, the code is on my website, quicknuclearscience.webs.com. You can download the code. You don't have to download it. Actually, it will pop up in your web browser. That's something I did. I'm really proud of how I did that because I really hate it when you have to download code when all you want to be able to do is just copy it from your web browser and paste it into your code editing software, so you don't actually have to download any files. So that's what you can do with mine, and then you can try deleting this delay 1. Well, this delay 1 you need. This if I is equal to 999 break statement, you can try to delete that or to keep it and see if it changes anything. But if you really just want to do exactly the same thing I did, then just leave that in, and my code worked fine, as you saw in the video. Okay, so that is the code. Thank you for watching this video, CrackSpider 101. I hope this helped you understand my code even better. If not, I will make another video, as long as you're not faking it. So yeah. So please, no bunch of comments that say the video is bad, I don't understand the code, just to make me do another video unless you really mean it. If you really mean it, and you can prove to me that you mean it, or that you actually care, because people who don't care and just want me to make another video on the same thing are not going to respond. So I'll figure out something to prove that you actually care about understanding this code. If you do, I will make another video, because I do like to be helpful. That's why I make these videos. Okay, so thank you for watching. Comment, rate, subscribe. Go to my website, which is quicknuclearscience.webs.com. The code will be under the files page. This code, in fact, it's already under the files page. So you just go to my website, go to the files page, click on the code, and it will appear just as text in your web browser, and you can copy it over without downloading anything. Also, if you don't have a YouTube account, if you go to my website, you can actually comment on my videos by putting in your email, and then you can comment without having a YouTube account. All you need is an email. Okay, so I hope you enjoyed the video. I hope that was helpful to you, CrackSpider 101, and anybody else who saw my other video. Thank you so much for watching. Bye.